So now we discuss the fourth experiment, that is ASCII to binary code conversion. So now here is the problem statement. The problem says that a number, ASCII number, is available in the memory location that is 2000, and we need to store the corresponding binary number or the result at memory location that is 2001. So here is the program. The program says that we need to load the HL pair with the immediate data which is available in the form of memory. So we load HL pair with 2000, and using MOV A, M instruction, what we do is we move the data available in the memory location to the accumulator. So the data, that is 32 data, comes in the accumulator. Now we subtract 30 immediately from the data available in the accumulator, that is 32, and after subtracting we compare the data with 0A. If we get a carry, then we get to the skip instruction, and if we do not have a carry, that means the number is greater than A, and then we skip this step and subtract 7. Okay, so here is the program, here is the instruction, and after the getting the result, we increment the memory pointer, that is INXH. That means after execution of the INXH, the HL pair will become 2001. That is the memory location of the result, and then we move the accumulator content into the memory location, that is 2001, and then we terminate the program. So here is the table. These are the memory locations, these are the instructions, and these are the opcodes corresponding to these instructions, and this is the remark. So at the very first 200 location we have a number, ASCII number, and on the next location we need to store the result, so we left it blank, that is 00, and from 2002 to 2011 we have program. This is the program, and we have written the opcode here. After writing the opcodes, for example LXI 2000 is 3-byte instruction, so 1 is the opcode for LXI, and next 2 is for the data. Similarly, move A, M has an opcode, that is 7E. Subtract immediate, that is a 2-byte instruction. First is D6 is the opcode and second is the data. Similarly, CPI 0A is also a 2-byte instruction. First is the opcode, second is the data. And then jump on carry to skip. A skip is written here, so we need to mention the address of the skip instruction in the next two commands, next two instructions. So these 200F is basically the address of the skip instruction, and DA is the opcode of skip. Then SUI 07, it's again a 2-byte instruction, so the opcode is D6, and since the 07 immediate data need to be subtracted, so 07 is the next. And skip has INXH instruction, which has an opcode, that is 23, and then we'll move the contents of the accumulator into the memory location, so we'll use 77 as the opcode of M, A, and then we terminate the program using HLT. Okay, here is the example. If we have 32, that means 32 minus 30, that is 02, and when we get 02 is less than 9, that means we have basically a carry. When we have a carry, that means we used to follow this particular instruction. That means we are not going to use SUI 07, however we skip to the next instruction, that is INXH. Now this 02 is the data left in the accumulator, and that need to be stored in the next memory location. So the data available in the accumulator is stored in the memory location, which is already incremented in the previous instruction, that is 2001. Okay, so 32 has the 32 is the ASCII code, and 2 is the corresponding binary number that is to be stored in a memory location 2000. So here is the snapshot of the simulator. First we need to reset. It looks like this. Then we need to put the data, that is 32. Okay, ASCII code, that is 32, and then we'll put the 00 in the result column. Next is on the next slide we use 2002 as the as to load the LXI instruction, that is given by 21, and the corresponding next memory location, that is 2003 and 2004, will have a lower byte address and upper byte address, that is 00 and 20. Next is, on the next instruction we use 7E, that is the opcode of instruction MOV A, M, so that we can move the data from the memory to the accumulator. Now we have different uh, operations and corresponding opcodes on next memory location. So here is 2006. What we do is basically subtract immediate data from the accumulator, and that is D6, the instruction, and that is the 30, because we subtract the data immediately, 30 data from the accumulator's data. Next is, after getting this, we'll compare it with 10. So FE is CPI. Next is 0A, obviously it's a 2-byte instruction, so CPI 0A, and then we'll go to again subtract immediate with 7, because if we get a carry then we need to skip, otherwise we need to subtract immediate with 07. So DA is subtract immediate with 0F, that is next data, right? The jump to skip, and then we use 200C for the next instruction, and D6 again. For the next instruction we use subtract immediate with 07 data. If the number is greater than 10, then we subtract immediately 07, and then the next instruction we use INXH, that is 23, output is 23, and then we use to store the data available in the memory location, available in the accumulator to the memory location using this 7, that is move M, A instruction. Then we terminate the program by using 76. Now we get the termination of the program. So after that we'll execute. So we'll put reset, and then we'll put go to memory. When we press reset, it looks like this, and when we press subtest memory, and then we put the 2002, because the program is starting from 2002, and then we execute the instruction. So after the execution, the screen will look like this. It says successfully executed, and now when we press the details, then this result will display. This shows the last execution of memory. Programming memory is the 2002. These are the affected flags, because we are using some operations, and that changes the flag status, and the registers we use is A, H, and L. So data memory used is this. So overall we have this corresponding data in the registers. These are the flags, and these are the memory used registers, and these are the memory that is used. So here is the data. In the 2001 we have stored the result, and that is 202. Okay, so here is the simulation of the program is completed. Now we are going to use the simulation of the program, that is by this animation. So first we reset, then we go to 2000, put the data, then we go to next location and put it 0, because we need to store the result here, and from next memory locations we'll continue to store our program. Okay, so one by one we'll be using different instructions based on the previous table we have already made using the instructions. And when we reach to the last instruction, that is HLT, opcode is 76, then we'll go to again press the reset key and go to execute the program by pressing the go, and then the proper memory location where our program is actually started. So here is the end, 76. Now we put the reset, and then we go to memory and then execute. It says successfully executed. These are the contents, and then we go to memory, that is 2001, and here is our answer, that is 02. Okay, thank you.